All right, just like number 12, we have another escape velocity equation. So right away, I just changed the the radius from kilometers to meters. All right, so there it is in kilometers. Um, there's 1,000 meters in 1 kilometer. The kilometers cancel, and so you just write the same number times 10 to the third. All right, and so here's the escape velocity equation. Of course, the escape velocity is the square root of, so it's 2 times big G, which is the universal gravitational constant, 6.67 times 10 to the minus 11th times the mass of this planet. So this is Venus, so it's actually very close to the mass of the Earth, just slightly smaller. So this is 4.87 times 10 to the 24th kilograms. All right, and then we divide by the radius, but in what I have circled right here in meters. All right, so it's going to be 6051.8 times 10 to the third. All right, so that's the formula. Let's plug it into our calculator, and we should get. All right, and so the answer comes out in kilometers. Sorry, the answer will be in meters per second, and then we'll just take whatever the answer is that we get. We're going to divide it by 1,000 to turn it into kilometers per second. All right, so the answer will be in meters per second. All right, so let's calculate that right now. All right, so all I'm going to do is this formula right here, and with this calculator, it's just easier to do 2 times. All right, so 6.67 times 10 to the minus 11th times, which the mass of Venus, which is 4.87 times 10 to the 24th, divided by, all right, so we divide by the radius in meters, which is 6051.8 times 10 to the third. And so we're going to say equals, but this is what's going to be underneath the radical. We still have to, so then we take the square root of that answer. All right, and so there it is. So 10,360 point, 10,361. It doesn't really matter because we're not rounding that far. So 10,361. 10,361. There's supposed to be a 6 in there. All right. And then, of course, we divide that by it. So that the answer in the numerator right there, that's when you just do the raw calculation. That would be in meters per second. Divide by 1,000. That changes it into kilometers per second. So notice there's the, it basically you move the decimal to right here. And so it would be 10 point, and then, it's 10.36. Since the 6 is greater than 5, we're going to round this up to 10.4. Right? So instead of a 3, we round it up to 10.4, and that answer is in kilometers per second, right? Which is exactly what I got earlier. All right, so that's number 13. All right, so here's number 14. The mass of Mars, that we're dealing with Mars now, and they give us the radius in kilometers. Find the escape velocity in kilometers per second. So in the escape velocity equation, the radius has to be in meters. It's in kilometers right now, so all I have to do is, you just, if you see the K, you can just simply replace it by times 10 to the third. Right? And now it's in meters. Right? And the same thing with, for example, if we were to change kilometers to centimeters, you just replace it by times 10 to the 5th. All right, so anyhow, here, let's write the equation. So the escape velocity, right, so this is from the surface of Mars, is of course the square root of 2 times big G, which is 6.67 times 10 to the minus 11th, universal gravitational constant. It never changes. All right, so times the mass of Mars here, which is 6.4 times 10 to the 23rd, E23, and then we divide it by the radius in meters, which is 3389.5 times 10 to the third. All right. And the answer that we're going to get is going to be in meters per second, and then we're going to divide that by 1,000 to get it into kilometers per second. All right, so here we go. All right, let's get the calculator. All right, so there's the last one we just did. All right, so again, 2 times 6.67 times 10 to the minus 11th times the mass, which is 6.4 times 6.4 times 10 to the 23rd divided by 3389.5 times 10 to the third. All right, so this is not the answer. This is what would go underneath the radical. All right, so, and then now all I have to do is take the square root of that. You know, most calculators, you just take the square. So anyhow, you know, you would just do the calculation all in one step. Anyhow, it's 5,018.8, 5,018.8. All right, and we divide that by 1,000. So it's going to be, let's see, what do we want to round it to? One place past the decimal. So the answer comes out to be 5.0, and you don't round up because the next digit is a 1. So the answer would be 5.0 kilometers per second. And that's the escape velocity from the surface of Mars. All right, so remember, compare that to the escape velocity from the surface of the Earth is about 11.5 kilometers per second. Let's try the next one. So here is, where's that recording? Oh, here it goes. Sorry, it didn't look like it was recording. So this is number 15. The mass of Venus is given to us in kilograms. The radius is given to us in kilometers. Calculate the surface gravity in meters per second squared. Round one place past the decimal. All right, so The one thing is we have to change the radius to meters. So it's given to us in kilometers. So if I just replace the K by times 10 to the third, E3, all right, now it's in meters. All right, so here's my surface gravity equation. A sub g, the acceleration due to gravity, is equal to big G times the mass. All right, so I'm just going to, times the mass, and then you divide by the radius squared. And the radius has to be in meters. All right, so let's put the numbers. It's going to be 6.67 times 10 to the minus 11th times the mass of, what is this? Oh, this is Venus. 4.87 times 10 to the 23rd. All right, that's in kilograms divided by the number that I just calculated. So this is 6051.8 times 10 to the third, E3, and you have to square that. Remember, you square the radius, or the distance from the center of the planet, or whatever it is you're trying to escape from. All right, so let's get our. So that's the formula. Let's put it into our calculator. So it's 6.67 times 10 minus 11th times 4.87 times 10 to the 23rd. I'm sorry, 10 to the 24th. Sorry, I wrote the wrong thing. I was thinking of Mars. Times 10 to the 24th. Yeah, I just realized that because it's Venus. All right, times 10 to the 24th. I'm glad I caught that. Divided by. All right, so this is my the radius of Venus. So it's 6051.8, or you could write just 800. It's the same thing. So 0.8 times 10 to the third, but of course we have to square that, right? And then hit n equals. All right, so this is the surface gravity, right? So it says to round it to one place past the decimal. So the answer is 8.86. All right, so since we're only rounding it to one place past the decimal, the 6 is greater than 5, so I'm going to round up. So this answer becomes 8.9. So 8.9 meters per second squared. That's just the units of acceleration. So on the Earth, it's a very famous. There's a very famous number that Galileo first discovered. For the Earth, the number is 9.8 meters per second squared. That's also known as little g, the acceleration due to gravity on the surface of the Earth. All right. So if you're on the surface of Venus, it would be very similar, very, very similar.